In this video, I'm going to demonstrate the proof of one of these other product to sum identities. I'm going to choose the cosine of alpha, sine of beta, and I'm going to prove it's equal to the other side over here. So there's many of these that we can prove. They've already proven one of them here. Now what I'm going to do is I'm going to come and I'm going to show you this one. It's really modeled very similar to the one they have there. I'm going to have one on record, and then you can do the other two if you choose to. So we have the cosine of alpha times the sine of beta. Now that's a product. We're going to change it into a sum, which is 1/2 of the sine of alpha plus beta, and minus the sine of alpha minus beta. Okay, so in order to prove this identity, the first thing we're going to do is we're going to apply the sine of a sum. So the sine of a sum identity says you take the sine of the first angle times the cosine of the second angle, then it's plus cosine of the first angle, sine of the second angle. Then we have minus. Now in this one we're going to apply the sign of a difference, that is the sine of the first angle, cosine of the second angle, then minus cosine of the first angle, sine of the second. And I need another parenthesis or bracket. So now I'm going to run through the negatives. So 1/2. We have sine of alpha, cosine of beta, plus cosine of alpha, sine of beta, then minus sine of alpha, cosine of beta, then plus cosine of alpha, sine of beta. Now what we're going to do is try to find the things that are like terms. So I want to see if there's any other sine of alpha, cosine of betas. Here's another sine of alpha, cosine of beta. Those two are going to reduce. And then this cosine of alpha, sine of beta, cosine of alpha, sine of beta, that makes two of them. So it's 2 of the, it doesn't matter if you go sine of beta, cosine of alpha. I guess we want it to look like the original, so let's come back and just keep it cosine of alpha, sine of beta. And if you take 1/2 of 2, it's a 1. So what we've done is we've proven that this identity does work, that the cosine of a product can be written as this sum. And we can verify it by using our sum and difference identities of a sine. Okay, so the others can be done in a similar fashion. Like I said, I'm not going to go into those since they are so similar to it. There are some problems in the homework assignment. If we get to those and prove those in that part, that would be just fine.